Okay, good morning, good afternoon, or good evening from wherever you are in the world that you're tuning in from. My name is James Wardlow. I am the System Sales Manager for PhaseOne Industrial in the EMEA region, and I'm joined by Derek Feebrey from Trendspek. Derek is the CEO of Trendspek, and it is our pleasure to welcome you to this webinar on asset management using Trendspek software and PhaseOne cameras to create high accuracy, true to life digital twins. During the presentation, we'll go over the various benefits of using PhaseOne medium format imagery for digital twin creation, the benefits of using medium format and the IXM. We will go over a small data collection that we made of a site here in the UK and showed some of the results. And then from that, I will hand over to Derek, who will make a presentation on the benefits of using high quality, high accuracy imagery inside the Trendspek platform for the use of asset inspection and collaboration. So to start with, we'll just make a quick introduction on our two companies. So I will start with PhaseOne. So PhaseOne was founded in 1993, so coming from the professional medium format photography market, so servicing customers and applications such as marketing, advertising, landscape photography. In 2012, PhaseOne extended the business into the industrial applications, so originally starting out in aerial photography, but subsequently since expanding into ground photography with machine vision, digitization of cultural heritage, and also ground inspection. On top of the hardware business, we also have the software business, which is facilitating Capture One, IX Capture, and then various other software packages facilitating the use of high accuracy airborne data. So PhaseOne is the market leader in medium format imaging. We are a trusted brand with more than 100,000 satisfied customers. So the global coverage for PhaseOne, so our headquarters are Copenhagen in Denmark, so that is the main R&D center for PhaseOne. We also have two further research and development centers in Israel and Japan. And then we have our network of sales and support in Denver, Colorado for North America, Cologne for Germany, and then further support and sales from Hong Kong. As well as our direct coverage, we also have more than 50 distribution and service partners spread out across the globe, which allows us to maintain a 24/7 customer-centric sales and support service. And all of this from the PhaseOne Industrial Airborne is supplying software and hardware solutions for 3D city mapping, in particular smart cities through oblique data capture. This is through some of our integration partners making bespoke sensors or customers themselves making bespoke systems. We're also heavily involved with traditional airborne mapping. So we have not only the individual medium format cameras, but fully integrated PhaseOne aerial systems. We also participate a lot in engineering applications, asset management, with the 4-band equipment, forestry, agriculture, research, environmental applications, infrastructure planning, power line monitoring, and open pit mining. On top of this, there are many more applications, and these become more varied the more our customers use the cameras for new and exciting applications. So I'll just hand over to Derek so he can make an introduction on Trendspek.
Hi everyone, thanks James. Yes, Trendspek has really been developed over the last 2 years. We've come from a background of drone services for asset inspection, and Trendspek was really the development through direct collaboration with several industries to match the way they wanted to work with drone imagery, and it was all built around being smart, simple and secure. So it's all designed to make use of digital twins, especially around collaboration with internal and external stakeholders to empower decision making.
Okay. So now we'll have a look at the PhaseOne cameras, in particular the IXM series for UAV, and we'll look at the various specifications that really put these cameras at the forefront of aerial imaging, and in particular the focus of this webinar on the particular qualities that really make it superior for the creation of digital twins and in general asset inspection. So just looking at the various or the basic specifications. So the IXM UAV camera is coming in two main resolutions. We have the IXM 50, which is a 50 megapixel medium format sensor, and then we also have the 100 megapixel sensor in the IXM 100. So as you can see, the IXM 100 is enjoying a dynamic range of 83 dB. It's got a pixel size of 3.76 microns and a high light sensitivity in ISO from 50 to 6400. All of these specifications and details are freely available on the website and in our brochures. The IXM series is also the first PhaseOne camera with IP53 weather protection and design, which protects it from ingress of dust or water splash. This is important in the UAV application, where primarily you're going to be outside, and it's really important for the IP53 certification to really protect the asset in that environment. On top of that, it also is having an FCC Class A rating, CE and ROHS. It's a compact and robust design at only 90 by 90 by 68 millimeters, and coming in at 630 grams without the lens. We managed to get the form factor down and make it workable for UAV by removing the LCD display, which was present on the previous generation of camera, and through this it was also allowed to extend the user case to enable the installation of external cooling systems, heating systems, or even external GNSS IMU solutions for more accurate post-processed image orientation and positioning. So the camera is equipped with the ultra-fast Sony XQD cards, as well as the internal storage on the XQD. We also have the ability to communicate to the camera through super-fast 10G Ethernet via SFP Plus module, as well as super speed USB 3. So this allows ultra-fast internal and external storage, which gives high-speed constant capture rates of 3 frames per second with the 100 megapixel, and 2 frames per second with the 50 megapixel. So let's start looking at the actual benefits of using a medium format camera. So the first major benefit is the actual sensor size. So the slide on the screen here now is showing effectively the difference in the various sensors that are used in typical UAV cameras. So we have right at the bottom there, we have the 1-inch CMOS from the Phantom 4 RTK. Then we have the 4/3 MFT sensor, which is typically used in the ZEMUSE X5S. And then we have the slightly larger APS-C in the Sony A6000 series, the ZEMUSE X7, and then the Sony A7R, which is using sort of a 35 millimeter full frame sensor. So this gives a brief overview just how much larger the medium format sensors are when compared to your typical UAV cameras. And the benefit really here from this is it allows you to enjoy greater efficiency, which therefore leads to a reduction in your project time. So typically a full frame medium format sensor is approximately 2.5 times the size of a 35 mil full frame. On top of this, the sensor also benefits from a high dynamic range. So it gives you wider operational capability in terms of your lighting situation. There's also less impact from high contrast capture environments, and this allows you in post-processing to essentially make adjustments to the highlights and the shadows. In a couple of slides, I will highlight just how much of a difference that does make. So first, looking at the actual efficiency side from the camera. So just a quick slide over a case study that was performed in the United States. The case study is actually listed, the link at the bottom of the slide. So you can take a look at that on our webpage, and there's even a dedicated webinar purely for this particular case study. But essentially what this slide is showing is the impact that having the medium format sensor has on your ability to be much more efficient. So all of the key outputs are highlighted in green. So we can see essentially the IXM100 when generating a 0.5 millimeter pixel resolution is flying at the same distance from the structure as a DJI X5 when it's only generating a 2.3 millimeter pixel. So with the medium format camera, it allows you to fly further from the structure, which allows you to have a bigger footprint while still maintaining a higher pixel resolution. And this in turn leads to much more rapid data collection, fewer images. So not only are you quicker on site when collecting your data, but you're also quicker in the office when you're post-processing that data. So that's one of the main benefits, is purely the efficiency from using a medium format and essentially the PhaseOne IXM camera. So back looking at a little bit more detail at the sensor itself. So again, as I mentioned, the IXM medium format sensor is enjoying a very wide dynamic range. We've achieved this on the IXM because typically with a standard sensor solution in a camera, it's using a front illuminated structure. And what is happening is when you are increasing the number of pixels on a physical sensor size, you have to physically reduce the size of the individual pixel. And when you do this, you actually reduce the amount of actual light that can actually penetrate that pixel. So you're actually reducing the amount of data that you can actually collect. So the way that PhaseOne have got around this with the IXM series, with IXM100, is it's the first PhaseOne camera with the new Sony backside illuminated sensor. So essentially what the backside illuminated sensor is doing is the metal wiring that would normally be placed on front of the photodiode to take the data from the pixel to the analog digital converter is now replaced onto the backside of the substrate, which then in essence is no longer blocking out any light. So it's allowed us to reduce that pixel size to increase the number of pixels on the chip, but without actually impacting on the high dynamic range. So with the backside illuminated sensor, it allows us the wide dynamic range, which gives us improved light sensitivity, and that equates to more flying hours per day and more flights achievable per year, and also allow us to maintain object resolution in low light conditions. So when we look at this in more detail, so the image on the screen now is from the recent data capture, which is all part of a case study that will be published and released, detailing the use of the PhaseOne cameras for digital twin creation. But what you can see here is one of the raw images, so no adjustments have been made to this. And what you can see already is there are some areas where we have quite dark shadows. And this, when you're using the data for asset inspection, you really want to have the ability to remove those shadows and reduce those shadows whilst not really affecting the quality of your data. So what the high dynamic range of the sensor actually allows you to do is in post-processing, you can actually make adjustments to the highlights and the shadows of the high dynamic range to actually bring out detail in the shadowy areas. So as you can see on the image on the left, it's the image is captured raw with no adjustments. And on the image on the right, we can start to see that shadow is a lot softer. You can now see detail coming out from behind that shadow. And it really allows you to get into all of the nooks and crannies of your asset target and really look for all of the details that you really need to be viewing. So to look at that in greater detail, so on the left we have an area zoomed in at 100% resolution. So you can see on the left is the unedited raw, still some quite dark shadowy areas where we can't see any detail. And then on the right hand side, we've really brought that detail out by making an adjustment to the shadows. And this then allows you to inspect what is behind or in that area of shadow, but without sort of reducing your image quality. So you're not compromising on the image quality to view the data. When we look on the other hand, so we flew the exact same target and modeled it with the DJI Phantom 4 with the 1-inch CMOS sensor. This is already producing a JPEG. So what this does not allow to do is to make any adjustments. So what we can already see within that data set is that there is that area which is very dark. You cannot get any information from that, and that might be on in your target data set. That might be the area where a crack is present, or something that you would ideally need to see to make some kind of a safety assessment. So that's one of the main functions, again, already with the PhaseOne camera, is the ability to really utilize that wide dynamic range and use that to your benefit to bring out the information that that is normally hidden with a typical UAV camera. The next major benefit with using the PhaseOne solutions is the lens solution. So all of PhaseOne's lenses are made specifically for an airborne application. So all the lenses are built to essentially support the required data quality that is necessary to make these digital twins and really maximize the quality of the data that's coming out. So for the IXM series, we have the RSM series of lenses. So we have a 35mm and an 80mm prime lens, which is for a mapping application. And then for the inspection applications, we have the RSM 80mm AF, the 150mm AF, and also a 300mm AF. And with the AF lenses, we have a motorized focusing mechanism internal to the lens, which allows you to adjust that focus distance of the lens to really get close to your object for inspection. So all of our lenses support high resolution with 120 line pairs per millimeter over a 55mm image circle. The lenses are created with a flat field design, which leads to low distortion characteristics. With the motorized focusing lenses, it allows us to focus from a range of 3 meters to infinity. All of our lenses are firmly and pressure stabilized for wide operation conditions. And also internal to the lens is the proven PhaseOne RS or Reliant shutter technology, which provides a lifetime of 500,000 cycles before service. And it's also good to note that every lens is inspected and calibrated for optimized performance. So what we can already see from the lens here, when we make a comparison between a PhaseOne image and a typical UAV image, is we can start to look at the actual image quality. And to do this, you generally, when you inspect or look at the quality of a lens, it's important to actually look at the center of the image, and then also look at the extent of the corners as well to check the quality. So what we've done here is essentially a comparison between the PhaseOne IXM100 with the 80mm AF lens compared to the DJI Phantom 4 with sections of the image from the center, top left, and the top right. So if we start with the center image, so the IXM100 is on the left and the Phantom 4 is on the right. So we can already see we've got greater image quality from the PhaseOne. Whilst the image is still quite sharp for the Phantom 4, it's not ideal. We can see big differences already in the radiometry. But then if we look at the image from the top left corner of our comparison, this is where we can start seeing the big differences. So with the PhaseOne camera, we can still see we've got perfect image clarity. We have sharp edges, there's no distortion, there's no blurring. Whereas when we compare that to the Phantom 4, we can quite clearly see here that what we end up with is quite a washed out image. The edges aren't sharp. We can clearly see that it's badly distorted. And when you take into consideration that these areas at the edges of the lens is where you are taking that data in the overlap areas to generate your tie points, the image quality across the whole band of the lens is really, really important. So then if we look at the top right of the image, again, we can see quite a remarkable difference. So with the PhaseOne, we're extremely sharp. We can see clearly the definitions of the image. We can see the undulations of the stonework. And with the Phantom 4, we've really got quite a poor image there with quite a high level of distortion. And then the other thing to really make notice of is just the vast difference between the radiometry between the PhaseOne and the Phantom 4 there. So overall, just a summary on the main specifications and benefits of the PhaseOne camera. So firstly, high resolutions are possible. So we can support resolutions of much greater than 1mm. So as shown on the first slide of the bridge case study, it was possible to generate a pixel of slightly less than 0.5 mm from around about 9 meters, whereas with a DJI Zenmuse X5S camera at 9.1 meters, you're generating a 2.3 millimeter pixel. So first, that allows you to have more safety distance, so you can fly further from an object, especially in the application of power lines. It protects you from magnetic interference, GPS occlusion, any impact on the UAV from turbulence, and also because you're further away from the object, you're getting a larger coverage. So that equates to less images, which again means shorter flight time, and then back in the office, it means a shorter processing time. And then on top of that, the wide dynamic range allows you to operate in a more varied lighting conditions. So all in all, it leads to a higher efficiency and much more safety for your investments. So we'll start looking at the actual case study that we generated as part of this webinar, but also it's a case study that will be presented on the website later on as a direct comparison between the model generated from the PhaseOne and also the model generated from the Phantom 4. So the actual subject of interest was Tupholme Abbey, which is in Lincolnshire of United Kingdom. It was a monastery building built between 1155 and 1165. It was later destroyed in 1536 during the dissolution of monasteries by Henry VIII, and later on turned into a Grand Tudor house by Sir Thomas Heneage. Around 1700, the Tudor mansion was actually demolished, and then on its remains was built Tupholme Hall, and this building also retained a sort of a trophy or an ornament, part of the original monastery wall, which is the part of the monastery which is still left standing. But by 1976, Tupholme Hall was finally demolished also. It's also interesting to note that the site during the early 70s was used for the Bardney Festival, and this entertained crowds with musicians such as Rod Stewart, Beastie Boys and Status Quo. So the actual collection and methodology. So again, we use the IXM 100, we use the RSM 80mm AF lens with the motorized focus. So we physically set the focus distance to 20 meters, so that was our subject distance, and this provided us a pixel resolution of 1 millimeter. We had an aperture of f8 selected, which provided a depth of field of 3.8 meters, which allowed us to get the full range of the object in focus. We based the triggering was on time-based triggering at 1 frame per second, and at the speed of the drone, which was manually flown, allowed overlaps of approximately 80% in both forward and lateral. The weather conditions on the day was cav okay, so no cloud, visibility was okay, which did lead to a little bit of a limitation, but we also had strong winds with 9 meters per second received on the ground, and we flew this with an M600 in collaboration with Copters from the UK. So in total, we flew 15 runs and captured 568 images from this site. It led to a flying time of approximately 15 minutes. We flew it with 2 sets of batteries. It would have been possible to fly it with 1 set of batteries, but we essentially split the project into the front facing wall and the back facing wall and flew it as 2 separate entities, and then in post-processing we amalgamated the 2 data sets together. So yes, the limitation for this project was that there was a big contrast in light conditions between the north and south facing walls during the day, and this would have been improved if there was a little bit of cloud cover just to reduce that large contrast. So if we actually look at the results themselves, it's unfortunately the video recording when applied to PowerPoint doesn't quite do the model full justice, but what will happen is the dataset will be loaded to the Trendspek website and loaded in as part of a trial demo set. So when you sign up, or if you choose to sign up for a trial demo set of Trendspek, then you'll be able to view the full model. But essentially with the model, you have the full representation at 1 millimeter resolution. You can clearly see the differences between the bricks. You can see the cracks. we still have good radiometry, and detail is exceptionally good. And yeah, as mentioned already, at a later stage when we do the full case study, which will be loaded to the website, there's also a comparison in there on the processing stages and the difference between the processing between the PhaseOne dataset and the Phantom 4 dataset. And the major difference was that during the creation of the dense point cloud between the P4 data and the PhaseOne data, is the PhaseOne data came out with a perfectly clean point cloud straight from processing, so no adjustments had to be made, whereas with the Phantom 4 a lot of manual effort had to be taken and done just to generate the final output. So now I will hand over to Derek, and I will let Derek discuss the benefits of using higher accuracy imagery in the Trendspek platform, and then also go over some of the main key features of Trendspek and how it allows you to take this data, create your 3D model, and then really use that for collaboration, annotation, and asset management in terms of data sets changing. So I will hand over to you, Derek.
Thanks, James. The big reason we like working with PhaseOne, and as James pointed out, really is based around image quality and the ability to efficiently capture really high detailed models. So we tend to be known for our modeling sub-millimeter per pixel, and that's really based on the ability to do remotely complete condition assessments and maintenance planning. So our intent is always to give true to life 3D digital models so that users know the exact condition of every millimeter while having that all at their fingertips. And we've seen Trendspek now used over in 25 different countries and across multiple different industries, from infrastructure, facilities like warehousing, shopping centers, oil and gas and LNG plants, power and water assets from reservoirs, dams and canals, towers, light towers and telecommunication towers, and then as well as road and rail. So when you've collected a lot of imagery and we're collecting these models, often still users like to also view the original imagery. So on the next slide there, James, we've built in our simple single click photo navigation. So any part of the model, all you need to do is just right click and you'll get your image with that point along with any image that contains that point. And you can go back and forth. So if you see something in the image, you can right click on the image and find that point on the model quite easily. So you can go back and forth. So one of the first big use cases is the ability to navigate a large photo set simply. From the imagery, as James said, it's really built around the ability to conduct condition assessments and maintenance planning remotely and across multiple people within an organization. So use cases are not just for asset managers, but we have multiple people collaborating on a data set, whether it be asset managers, executives and directors, in-field technicians, as well as the ability to share it externally with contractors and specialists. So on the next slide, what we've built is what we call our Annotation Card system. So effectively your filing cabinet for a particular point or defect. So you can see that the first tab will contain all the geospatial information, the ability to change icons and colors, as well as include descriptions. Then you can click on a tab and have all of the associated imagery that went into building this model, as well as the ability to have custom defect drop downs, so you can have different failure modes, severities, or even any custom section. We also have the ability to chat, so think of it as your WhatsApp chat that can contain with the defect, along with things like history. It can be used as a Dropbox to include files, work orders, additional imagery, and we can also share this card externally to email addresses. So it's a bit of an overview. And it's the same type of card, for instance, with measurements, where you can measure distances, surfaces, height changes, and slopes, as well as area and volume. So while the card, the first page of the card will stay the same, will change with the different functions, the rest of the card is very similar. And that's the same with our new antenna mode, which can give you tilt, azimuth, heights, where you can also set a relative height. Say, for instance, in a telecommunications tower, you can set the base plate, and then all the measurements will be in relation to that base plate. So these cards form a way for multiple people to log in and add, change, and collaborate on a particular defect in real time. So on the next slide, you will see we may end up with hundreds of these cards. So we've also built in the ability to sort them out into different lists, as well as you can create folders and filter through them. So you should be able to see that on the next slide there. So it's a really designed to give a good way to manage an asset and to keep organized and to have the right data at the right time. So for no matter who within the organization. So if we do end up, we can also, from this view, we can change, or we can toggle on and off what defects or what annotation cards are being displayed, as well as the ability to add labels to them. And anything we do have selected, all we need to simply do is tick which ones you want to include in a PDF report, and then it's a single button to generate, and that goes straight to your email address in just a few minutes' time. So that's the next slide there. And then, so you get presentation ready reports, so they can be quickly fired off to management, to contractors, to in-field technicians. They can be sent anywhere at any time. But where we really got our name from was layering information on top of each other. So on the next slide, we've built a couple of different trend tools. So if we've captured, so this captured in 2020, and we have captured the same asset back in 2018 and 2016. So we can start layering this model on top of each other. And we can do that either in a side-by-side view, which is synced. So you can inspect any part of it and have a direct representation of what it used to look like. So we can start monitoring trends, or if we've identified a defect, we can then go back and compare how that defect looked last time. So you can see we've gone back to 2016 there. The other way then is to also do it in a timeline slider. So if we want to measure or map out trace cracks or circle corrosion, we can then view that particular part of the model back in time, just with a simple timeline slider. So this really helps in asset management, either monitor the trends to really plan out predictive maintenance schedules, or it can be used to go back in time and try and identify when a defect started or the potential cause of a defect. So working with asset managers all over the world, there was on the next slide, the big part of it was user management. They wanted it to be smart but simple to use, because this could flow through an organization and training time is a big consideration. So our focus has always been to deliver really comprehensive and powerful data, but in a very simplistic way for everybody to use. It had to be secure. So Trendspek is fully ISO certified, not only in quality, but also in information security. And the next big part was they wanted to be able to control what they were sending out to other people, who had access, what they could access, and down to a really granular level. So I could share it with, say, a tenderer who I'm trying to get to do a scope of works. I'll give them permission to be able to look at certain annotation cards, but not be able to add or delete or chat. So we've really gone granular with permissions and that whole security management system behind it. So we can delete people, we can control, or we can keep really detailed audit logs on when the data's been accessed, by who, how often, which is really a big compliance piece, especially these days around cybersecurity. So that's a bit of an overview of what Trendspek does. And as I said, it's really designed for teams to collaborate on asset data, and the big part of it is the imagery that goes into building these photogrammetry models. And having a camera like a PhaseOne not only lets you achieve the really high resolution models that we tend to be known for, but it makes it efficient. So if we're talking about some structures that may be thousands and thousands of photos, I think one of our biggest one is nearly 15,000 photos that has gone into it. You can start to see where, compared to something like a Phantom 4, which may take 10 hours of flight time, and 10, 20 times the amount of imagery, using something like a PhaseOne camera, it gives better model quality and in a much shorter time. So instead of 10 hours, it could be done in less than an hour type thing. So we've seen a lot of PhaseOne data sets come in, and they've always blown people away in terms of the quality. So yeah, as James said, we'll make the Abby available if you wanted to check out and have a look at it in real time and play around with some of the tools and features that we've got on offer. But thank you for taking the time to listen, and back to you, James.
Yeah, thank you, Derek. Yeah, very informative on the features of your software and how it is a benefit when combined with the PhaseOne imagery data. So essentially, we are at the end of our presentation. So once again, thank you all for joining. We'd like just to now take the opportunity to answer any questions that you might have. So I think my colleague Tina has been keeping an eye on the questions tab, and will ask us some questions.
Yes, absolutely. So we already had several questions coming up during the presentation, but I just want to invite the audience, if you have any questions, to ask them now, so we have the chance to answer them during this webinar. So the first question is for Derek, and it's regarding data processing. So someone asked, how is the data processed when uploaded via the Trendspek service?
Trendspek, all the operator needs to do is, once they've captured it on site from our dashboard, they simply upload the imagery and that's it. Upload and walk away. We take care of everything. It'll go into our processing engines, and then you get notified once the data set is live in their account. But it's a very simple process.
Okay, thank you. The next question also for Derek, is the Trendspek service available as a subscription?
It is. It's a software as a service, so it is run on any web browser. And we've worked hard on delivering the fastest user experience. So we have clients, especially in government, that may have 5-6-year-old laptops with no graphics cards or anything in them. They run Trendspek without any problem in a web browser, but it is on offer as a subscription service or as a pay-as-you-go service as well.
Okay, thank you. So I'm just looking to see if there are any other questions coming up. Is there a chance to get a copy of the raw files also? That's another question just coming up.
Yeah, I can answer that one. If somebody would like to get hold of the raw data and run it through any software or have a look at the process results already through Trendspek, we can certainly make some copies of small portions of the data set available. But that's on top of that, as mentioned previously, we are also running a case study shortly in the future on the actual data set as a whole and the processing stages and steps, and really to go into more detail in the difference between using the PhaseOne camera compared to the Phantom 4. So yes, there are not only the raw data files that are available, but there's also the process version through Trendspek, and also the case study to also come forward.
Okay, thank you, James. This was the last question for the moment, so if anyone has any questions, please ask them now. And I'll hand back to James.
Okay, so if we have no more questions, then I'd like to finish off by saying thank you for joining us for this webinar, and thank you especially to Derek. It's already very late in Australia, so thank you for taking the time to co-present with us and really detail the advantages of the PhaseOne imagery and your platform for the remote data analysis and trend monitoring. So yeah, once again, thank you very much for your time.
No, it's a pleasure. Thanks for having me. And yeah, as I said, we really do enjoy seeing a lot of the PhaseOne data sets come through. They never cease to amaze.
Perfect. Okay, well, thank you, and we'll look forward to hearing from you again soon. Thank you. Bye-bye.
Bye-bye.